right, so if I've got a negative 2x is less than a negative 10. Okay, that's a one step. We would, to solve for x, we would what? Divide both sides by the negative 2. All right, if I am multiplying or dividing by a negative number. All right, well, if I show my algebra steps and I go divide by negative 2, did I divide by a negative number? Yes. So in other words, if the number with the x is negative, then that means I'm going to flip the inequality symbol. All right, the algebra steps stay the same. Those negative 2's cross out. I'm left with an x. All right, but now, instead of having a less than symbol, I have to have a greater than symbol. All right, so that flip occurs. Two negatives are a positive, so then I'm going to have a positive right there. All right, so the thing here is this gets flipped, and it's because the negative 2 in front of the x. All right, now let's suppose I had a 4x is greater than or equal to negative 12. All right, am I going to flip that one? Am I going to flip that one? No, I'm not going to flip this one. All right, because if I divide by 4, that's a positive number. All right, the 4's would cross out here. There's no flip. Okay, so when I get done and I answer this, we'll write no flip. All right, so this is going to be a what? An x. I do not flip it. I keep the same inequality symbol, greater than or equal to, and then I get a negative 3. So just because that negative 12 there was negative, it makes no difference. The thing I am looking at to do each one of these is the number in front of the x. If that number in front of the x is negative, then that's when I flip it. So this one is, I'm just going to put flip under here because it was negative. I'm going to put no flip on this one, just in case when you go back and you look at your notes, it'll make a little bit more sense. Okay, now without working them out, let's not work this one out. Let's just look at it. What if I had an x over a negative 2 is less than an 18? Is it a flip? Yep, it's a flip because I find my x, I find the number with it, and if it's negative, then yes, I would flip this one. So I'm going to put flip over here. I'm not going to actually work it out. Let's do like 1/3 x is greater than or equal to 12. Am I going to flip the inequality symbol on that one? Bryce, am I going to flip it on that one? No, because what's not negative? You said it. The thing in front of x. Yep, the thing in front of x is not negative. That 1/3 is not negative, so we would not flip the sign. Okay? So, you're not just going to do one step inequalities. Those are kind of boring. We know how to do distributive property. We know how to do x on both sides. All right, so we're going to do a little bit more challenging ones. The only time you have to worry about flipping is when you get down to the very end and you are multiplying or dividing. So there's no flipping during the middle of the problem. Okay, no flipping during the middle of the problem whatsoever. Okay, so let's take a look at maybe just a two-step. We'll work our way up. All right, let's suppose we've got like a negative 2x, and then it's minus 8 is less than a negative 12. All right, that's just a good old-fashioned two-step inequality. The only difference is instead of having an equal sign right there, I've got my inequality. All right, so first thing I'm going to do, I'm going to do the opposite. What am I going to do to both sides? What am I going to do to both sides? Yep, Jake. Add 8 to both sides. So I'm going to put a little plus 8 right there. Put a plus 8 right there. These type of things we got to be really good at. I'm going to bring down the negative 2x. I'm going to keep the inequality symbol. All right, and if you didn't, if this did not happen to you on the previous homework, it will today. All right, the more steps we have to do, you're going to get, you're going to just like go through so fast, and you'll accidentally put an equal sign right there. Okay, but you want to always pay attention. Whatever that symbol is, bring it straight down. All right, negative 12 plus 8. Negative 12 plus 8 is, what's that? Negative 4. All right, now I'm going to divide by what number? I'm going to divide by negative 2. Do I need to flip the inequality? Yep. So I divide by that negative 2. All right, I don't flip it until I get down to this last step when I write my x. Then I flip it. And then 2 negatives make a positive, so then this is positive 2. Okay, so we'll still have those answers. You're going to have to pay attention to the directions because maybe they're going to tell you to solve and graph. If they tell you to solve and graph, then we would graph this. Let's do that as a review from Monday. All right, what number goes in the middle of our number line? Nope, not 0. Yeah, 2. Well, no, that's okay. You weren't here. Whatever number that is, we want that number in the middle because if that number was like 200, I don't want 200 hash marks out from 0. So we're going to put that one in the middle. What number goes on the right?
3.
A 3. What number goes on the left?
1.
A 1. All right, is it going to be an open dot or closed dot on my 2? Open dot. All right, now this says x is greater than 2. Where are the numbers that are bigger? 3, 4, 5, 6, 7. So we're going to shade out this way. Shade right on that number line, and then fill in the arrow at the end.
So an open dot is the ones that the middle does not have a line.
Yes, ones where the middle does not have a line. Yes, that's a very good way to put it. Yep, because we're not including it, because think of it like this. All right, the number, I'm shading these because these numbers make this true.
Okay.
If I take 2 and I put in there, is 2 greater than 2? No. So see, I don't want to shade a 2 because when I put 2 in, it does not make it true. So the open dot is saying we're not going to include 2, but we're going to include everything bigger than 2.
Oh.
We are shading, all these numbers that we're shading over here will make that sentence true. All right, so that's a 2-step. We know how to do 2-step equations. All right, let's suppose we've got one with maybe x on both sides. So let's do like a 4x minus a 3 greater than or equal to a 2x plus a 10. Again, this may not come out even. They don't always have to come out even. All right, so this has got x on both sides, just like the ones that had equations, x on both sides. So it means what? We move all the x's to the left. It's been a while since we've done that. So I'm going to take this 2x. What's the opposite of positive 2x? Yep, minus 2x. So I'm going to do minus 2x. Then I'm going to come over here to this side, and I'm going to draw it right underneath the like term. 2x minus 2x crosses out over there. And I believe when we did this all in the same step. This 3 has to go over to the right-hand side. Right? Because we're moving numbers to the right and letters to the left. Okay, this is a good review for our equations. What's the opposite of subtracting 3? Plus 3. So I'm going to plus 3 here. This one and this one's going to cross out. I'm going to put a plus 3 over there. So the 2 middle ones always cross out when we do it this way, all in the same step. Okay, so 4x minus 2x is 2x. The symbol, same symbol comes down, so don't accidentally put an equal sign. 10 plus 3? 13. All right, is this going to be one where I'm going to flip the inequality or not flip it? Not flip it, because I'm going to divide by that 2. So I'm going to divide by 2, divide by 2. All right, now 13 divided by 2. Doesn't come out even, but can we do a mixed number? 6.5. So x is greater than or equal to 6 1/2. All right, now do we remember how to put the 6 1/2 on the number line? 6 1/2 is in between what two numbers? 6 and 7. So if you have a mixed number like this, put the two numbers that it is in between on your number line. All right, now 2 1/2 is kind of easy because if you're going to estimate that, should you estimate exactly halfway through? Yeah. All right, now open dot or closed dot? Closed dot. All right, I'm not overly concerned about labeling that, but if you would want to label it 6 1/2, you can. All right, if you do, just don't put a hash mark. All right, I just put the dot on there because your hash marks on a number line represent your integers, and 6 1/2 is not an integer, so we don't want a hash mark there. All right, now this says x is greater than 6 1/2. What are the numbers that are bigger than 6 1/2? 7, 8, 9. So we're shading to the right. And depending on how long you make your number line is how much you got to shade. Okay, so any type of equation that we have already solved, then you should be able to do the exact same thing because that symbol in the middle you don't touch, you just bring down. Okay, you still do all your same algebra steps. Let's go ahead and do another one that happens to have maybe distributive property in it and x on both sides. All right, so what do I have to do first? Distributive property. If you see a set of parentheses, you're going to distribute first, right? Here's your set of parentheses. I do have x on both sides. I'm not going to be worried about that to begin with. I want to do this distributive property first. All right, so -2 times 3, -6x. Okay, so I'm going to go ahead and write everything else down here. 4x plus 2 greater than, we said -6 with an x. All right, how about a -2 times a -5? Positive 10. All right, now once I do that one step, it looks just like the one that we just did. I have an x and a plain number on the left. I have an x and a plain number on the right. So we're going to move the x's to the left. We're going to move this 2 to the right. Okay, so what am I going to do to the 6x to both sides? I'm going to add it. So I'm going to add 6x. I'm going to come over here, add 6x underneath that x term, so that these two things go away. What am I going to do to the 2? I'm going to subtract 2. So -2, -2, these two fall out. What's 4x and 6x is 10x. Don't accidentally put an equal sign. Make sure you look back up and do the exact same symbol. All right, 10 minus 2, 8. All right, do I have to flip the inequality on this one? Nope, I'm going to divide by 10. Does 8 divide by 10 evenly? No. Okay, so now remember what we did? We've done mixed numbers, we've done that sort of thing, but if I cover this part of the problem up, that just looks like the fraction 8 over 10. Maggie?
Why would it be plus 6 and not divided by 6?
Why would it be, say that again, why would it be?
So at the top, why would it be plus 6 and not divided by 6?
Because I'm taking this term is being added, so when I move the whole term, I'm going to do the opposite of add or subtract. Does that make sense? Okay. All right. Now, back here, if you cover up the entire problem with your hand, that looks like 8 over 10. You can leave it as a fraction 8 over 10. Okay, because it doesn't divide out evenly. Can I take 8 over 10 and reduce the lowest terms? 4/5. Okay, so we just want to write x is greater than 4/5. What two numbers is 4/5 in between? 0 and 1. Yes, very good. 4/5 is in between 0 and 1, so I'm going to put my 0 on my number line. I'm going to put my 1 on my number line. Okay, now, next question. Is 4/5 closer to the 1 or closer to the 0? Closer to the 1, because if it was 5 over 5, it would be exactly 1. So it's going to be closer to the 1. So you're just going to estimate it. Do I need an open dot or a closed dot? Open dot. I'm just going to estimate it right about there. I'm not even going to worry about labeling it because you don't have to label it. Clearly I know that. We're good there. Wow, every one of these have been greater than. X is greater than 4/5. The numbers that are bigger are to the right. So unfortunately, every example I did was shaded to the right. Will we always shade to the right? No. Just by coincidence, the way I kept putting the symbols in there. Okay, now you definitely want to read the directions. Okay, sometimes it's going to say just solve. If it says solve, you're going to do all of this and then you'll stop right there. If it says solve and graph, then you got to add the graph. Okay, but you want to read your directions because if it just says solve, you don't want to waste your time doing all those graphs for nothing.